So part 2 of our first lesson is an executive summary of this nature of science and the stages which it goes through. So remember to just log in with Google to get to Perusall. You should have already joined the class. If not, the join code is applied here in the enroll in course section. And that join code is on the syllabus that we just showed. Right over here, go to the top. That's the course code right there. Once we're in, we go to our Physics 20 course. We are in our preliminaries unit, specifically lesson 1. So that is the video that we've already recorded. This is a new one. So we are dealing with the nature of science and understanding the scope and sequence of science here. For now, we'll close that just to fill a little more of the screen. So science is less about a collection of facts and theories and is more about a scientific method and a process by which we do everything we can to make sure that we're getting things right and make sure we haven't misinterpreted the evidence in front of us. So we start typically with a hypothesis. Most of the hypotheses we use will be fairly specific. Say an if-then statement: if I drop my mother's favorite expensive crystal sculpture, then it will fall. Or if this expensive crystal structure falls on the hard floor, then it will break. Or if this breaks, I will need to enter the witness protection program. These are hypotheses. So we start with that. In some cases, a hypothesis might just be these two quantities have some sort of connection. So we change one, see if the other changes, and if so, does it change in a predictable way? Now, often at the high school level, we'll skip the next 2 steps and jump right to the discovery and the verification experiments. But we will do a grant application as our next step. So you get the funding to test your hypothesis. Now, from there, we'll often go to discovery. There's an optional intermediate step that we will talk about in a little more detail in a later lesson, but sometimes we'll do a pre-publication paper saying we are doing this experiment, we expect to publish on this date, and these are the results that we anticipate we're going to get. And that's a way to maintain academic honesty and sort of stake your claim if someone else starts doing the same sort of research. It is useful to keep track of those pre-publication documents, because if you've got a $2 million grant to a particular research project and someone else is a week away from finishing, the people who want to provide you that grant might get upset that they're not getting credit for the discovery. Because unfortunately, that's where a lot of grant money comes from. It would be from the private sector that are looking to make a profit off this, but they can only do it if they own it. So by doing that pre-publication paper, you sort of mark out the territory and people know, oh, they're probably going to beat us to it. They will own anything that comes out of it. Let's invest in something else. Okay, so next up is the discovery experiment. So this is where we actually put the idea to the test. Now, one key thing, no experiment can say the hypothesis is true. Okay, science does not work that way. We're going to see concrete examples of that coming up. There is a certain amount of uncertainty in any measurement. We'll learn more details on that in Physics 30, but there's actually a limit to even how accurately things exist, if that makes sense. So we can never say with absolute certainty that something is true. We can say that it might be the truth. What we can do is define a window of possibility in which the truth lies. And we can say whether something is in or out of that window, but as we get more and more data, we can narrow that window, and then something that was in that window isn't anymore. And that's where science excels. So science excels at figuring out what is false. They can eliminate possibilities. So as was attributed to Sherlock Holmes, Once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. So after a discovery experiment, we either concluded that the hypothesis is false, or we don't. If the hypothesis is false, we throw it away, we modify it, but if we cannot eliminate that possibility, then we'll move into the next phase. When we're writing our lab reports, the vocabulary is that the experiment is either supported, or the experiment either supports or does not support the hypothesis. So a verification experiment says that after the original discovery experiment, the rest of the scientific community will try to reproduce it and see, okay, is this a coincidence that the lab worked out, or is there something genuinely here? And they will keep trying and refining it. And if it stands up to those tests, then it gets upgraded to the status of theory, and we just start applying it in the future. We have accepted that as the truth as far as we can understand it. So here's a little bit more talk on those pre-publication papers and what goes into those. Our focus in this course will be on discovery and verification experiments. Those will be our focus. If the equipment is in the school, we will physically do the lab as often as possible. And again, pandemic permitting. If it's not physically in the school, then we will go another route. Anyway, as is going to be typical through the course, the assignments that go with the lesson, if they are not out of the physical textbook, that Pearson physics book, or Khan Academy or iExcel, then this is where we will likely find them, and your Google Classroom will tell you where they are. So we have actually just 3 assignments that are 1 question each for this first lesson, sort of start the year off a bit gently. But that is the core of our first lesson of the year.